we worked on, so in parallel, it's a complete coincidence, we worked on exactly the same, almost the same use case together, which is an interactive graph. You worked on it for a client project, I worked on it for a YouTube video. And I remember we started to communicate because also you found bug in Redash, and I was also updating Redash exactly for these specific use cases, so that was pretty fun. And in this graph interaction use case, so we have data points, so just some single values. So if you plot these values, you have straight lines. And the first thing we need to do is to transform this straight line into nice curves. And here there are many algorithms we can use to do it. Then we need to morph from, so now we have sequences of Bezier curves from data points. And then we can, I don't know if you do it in your app, but in the demo I show on YouTube, we can morph from one Bezier curve to another. So if you switch from one graph to the other, and then you can drag a cursor along the path. And so Bezier curves are 4 values, essentially, cubic Bezier curves, a start point, a control point 1, control point 2, and the destination point. And there is this t parameter, which goes from 0 to 1. At 0, you are the starting point. At 1, you are the destination point. And the 2 control point defines a curve that will make you go from the start point to the destination point. And yeah, with t going from 0 to 1.
Yeah, right. So for me, what helps me visualize it is that, so you always have the start and the end point. So it's clear that the line must in some way go from the start to the end. And then you have these control points, which kind of tell you the direction of where the line is going. So it starts with a tangent that is aligned from the start to the first control point. And it ends with the direction that is given by the tangent between the start, between the endpoint and the last control point. And then basically you just animate the direction.
Yes.
Which is the key to giving these very smooth curves, which are super rounded.
There are a couple of really great resources to learn about Bezier curves. I learned everything that I know from a document from Pomax called A Primer on Bezier Curves, and it's an absolutely incredible document, especially for us because it's done in the perspective of a programmer. A programmer who wants to do actually cool animations and things like this. Because I guess the topic of Bezier curves is so vast, and here it's really in the targeted for programmers, and so everything that I know is based from this document. And then in this document there is also some really cool use cases which I didn't have on my animation use cases the need for, but I almost wish there are some chapters about 3D stuff, about seeing Bezier curves as matrices, where I don't have a use case for it, but I almost wish, I wish I could play with these tools. But all the recipes are given in this document. Absolutely incredible. Like, for instance, also solving, finding the Y value. If you have, so to drag an object along a path, the whole algorithm, the whole math behind is given. It's absolutely cool.
Yeah, it's like kind of crazy that we are only scratching the surface here. Like usually we use like Bezier curves with a few control points, but you could add a lot more, and you can even go into the third dimension. These Bezier curves are like a super universal concept that can be used for a lot of stuff. Did you actually know why the Bezier curve was invented?
So I know it's a French guy called Bézier.
Yeah, that's right.
I don't know his name.
So I googled it once. It's Pierre Bezier.
Pierre Bezier
is indeed a Frenchman.
He works for Renault, I think, and I guess he was a designer. He was designing cars, and that's how he came up with.
Yeah, right. So they wanted to make the car really a really nice curve. That's common thing in cars. Like the car companies compete who has like the nicest shape of the car, and how do you make a really nice, rounded, elegant curve? Of course, with basic curve, and this is kind of how it started. It's like the Pierre Bezier. He came up with a formula which eventually became known as the Bezier curve, but it was a car shape initially.
The interesting thing is it's actually a recent mathematical tool, actually. I think it was invented in the last century. And because some of the other math we're using are much, much older. But yeah, shout out Didier Bézier.
Yeah, Pierre Bezier, man, what a great guy. I think he only a legend, really.
Shout out.
A legend for us because Bezier curve is so universal. We use it in so many places. I also think he only passed away not so long ago. I think in 1999. So that shows you that
it's a
quite a late invention.
Yes, absolutely. In the case of the interactive graphs, there is a Rainbow app, which is an Ethereum wallet, which is open source, which is done by an amazing team of React Native developers, most notably Michal Ozdanik from Reanimated Gesture Handler React Navigation. The app is open source, and the interactive graph part of the app is also a standalone package on NPM. And they gave a lot of these recipes, right? How to do the curve smoothing and finding the Y value for any X values. What we did, right, is, for instance, to do the smoothing algorithm, we needed to run it on the UI thread. So we just copy-paste some of the code and repackage it to Redash with the Worklet directive. Sometimes we just need to... It's funny because there are lots of NPM packages which we can use on the UI thread, but we need to repackage with sometimes just to add the Worklet directive.
Yeah, it was quite the challenge for me. So my boss came to me and said, this animated graph that you have, it's great. It has smooth curves, but now I would like that you could hold the finger and drag the graph. So that means that if I drag the graph to the left, that there would be like some more data points coming, and I would have to recalculate the whole curve. So I try to do that. Of course, I go to reanimated helper library redash, and there it said, well, actually the parse function cannot be used on the UI thread.
That's correct.
And the reason for that is because it depends on some other NPM packages like SVG, like an SVG path properties, SVG absolute path, and these were not declared as worklets. So it was a bit of a stepping stone for me at first, but then I talked with you a bit. I talked with you about it, and we kind of improved the whole path generation pipeline a bit. And basically I used like a function from this reanimated chart tool to generate the path, and was then like transforming it back using the parse function. And we found out like a really nice solution where it turns out that you don't have to serialize and parse the path again. That was amazing.
You go directly from data points to Bezier curves. Yeah, it's interesting because the mental model I have for these animation worklets is the one of OpenGL shaders. So they're very similar in the sense that they are pieces of codes to be compiled, executed on an isolated context. And if you deal with OpenGL shaders, it's hard to do things like having shaders depending on each other and integrated with your code. So maybe you have like some sort of templating, also having like their strings, right? So maybe also you need some plugins to have some syntax highlighting and so on. Here with Worklets, the integration is much more seamless because we have the Babel plugin that extracts all the dependencies and so on. So you can easily, it's all JavaScript. You can easily have worklet functions invoking other worklet functions using constants which are shared between the JavaScript thread and worklet functions. And I guess that one step that will come in the future is that for us to be able to import such packages on the UI thread and to have a way to process them. To build, I'm not sure how to build a bundle on the UI thread or something.
Yeah, for sure. I mean, these things are not for granted. We have these functions within npm packages that we could use and workletize maybe in the future.
Mm.
In a shader language, you cannot import an npm package. That's a completely different language. Whereas the worklet, it is JavaScript, and there's a nice bridge between the code that we already have and the one that we want to run on the UI thread.
Yes. And until then, that's for sure. In Redash, I'm going to take sometimes some utility functions and simply copy paste and add the worklet directive. I think I did the same for cubic roots solving, where I think you have an npm package that does exactly that, but I just had to copy paste the function and add the worklet directive. But that's already pretty good. I mean, in compared to version 1, that's already a giant leap, and I'm sure that in the future there's going to be even more integration. And last time we talked about Reanimated 2, we also mentioned more static analysis between these two contexts, right? So I think the relationship between JavaScript thread and UI thread is going to become much more sophisticated. So we'll probably have ESLint plugins that will understand these differences, and we'll probably also have ways to use npm packages